Have you ever wondered how many atoms make up a single molecule of an element? Today, we're diving into the world of atomicity, the unsung hero of chemistry. Picture this. Atomicity is like the number of players in a game of catch. It could be a game of two, a whole team. Similarly, atomicity tells us how many atoms are in play within a molecule of an element. Atomicity is the count of atoms present in a molecule. This count helps us distinguish between elements that exist as single atoms or as clusters of atoms. Consider noble gases like helium or neon, or some metals like mercury. They're the lone wolves of the element world, with an atomicity of 1. Essentially, one atom equals one molecule of the element. Then we have the atoms that like to pair up, like oxygen and nitrogen. They have an atomicity of 2, indicating two atoms bonded together form a molecule. Sometimes the atomicity goes beyond pairs. Take phosphorus, for instance. It exists as a molecule with 4 linked atoms. Now you might ask, why does atomicity matter? Well, it serves 3 main purposes. Firstly, atomicity helps interpret chemical formulas. These formulas show the composition of elements and compounds. For instance, the formula for oxygen gas, O2, tells us that 2 oxygen atoms make up one molecule. Secondly, atomicity is crucial for balancing chemical equations. These equations depict reactions between elements and compounds. Knowing the atomicities of the elements involved ensures the conservation of atoms on both sides of the reaction. Lastly, atomicity influences the properties of elements. For example, elements with an atomicity of 1, like helium, are gases at room temperature. In contrast, elements with higher atomicities, like sulfur, can be solids. Atomicity can sometimes change under specific conditions. For example, oxygen can form molecules with 3 atoms, creating ozone. But the core concept remains the same. Atomicity tells us how many atoms come together to form a molecule of an element. So remember, the next time you encounter a chemical formula or equation, those numbers aren't just numbers. They represent the fundamental building blocks of matter. They reveal the number of atoms involved in the grand game of elements. Atomicity, in essence, helps us understand the rules of the game.